How's it going, everyone? This is going to be a walkthrough of some common questions that have to do with linear regression and correlation. So we have the cost of a product in different years from 2000 to 2023 was plotted, and the line of best fit has the equation y equals 48x minus 94,000 with an r-squared value of 0.67. And we have some questions about that. So the first one, according to the line of best fit, what was the price of the product in 2010? So according to the line of best fit, well, the line of best fit tells us the price of the product, y, and how it depends on the year. And how it depends on the year, it's 48 multiplied by the year minus 94,000. Now the year we're interested in here is the year 2010. So we just have to put in 2010 for x. So we have 48 times 2010 minus 94,000. So 48 times 2010, that gives us 96,480. And that minus 94,000 is going to be 2,480. So according to the line of best fit, the price of the product in the year 2010 was $2,480. So we can deduce then that the actual price was somewhere around there. And considering the r-squared value, 0.67, which is pretty good, the price probably was somewhere around there. Now part B asks us, by how much is the product expected to increase or decrease in price over the course of 5 years? Now, that's asking about this part of the equation here. The part of the number in the equation that multiplies x, that's called the slope. And that's how much you expect the y value to change if the x value increases by 1. That's why it's the value that multiplies x. So if x goes up by 1, y is going to go up by 48 because it's a positive 48. If x goes up by 5, as it says here, 5 years, well then y is going to also increase by 5 times 48. And that's our answer. So 5 times 48, 48 being our slope, and that gives us 240. So in 5 years, we expect the price to increase by 240. So that's part B. Part C asks us, what is the coefficient of correlation? Well, the coefficient of correlation is r. Sometimes it's a lowercase r, sometimes it's an uppercase r, depending on where you're seeing this equation, what software you're using, what paper you're reading. And we're given the r-squared value. The r-squared value is 0.67. So the r value is going to be the square root of that. Now, if we know that r squared is 0.67, well, then r can be the positive or negative square root of r squared. In our case, should it be positive or negative? That depends on the slope. If the slope is positive, then it is a positive correlation and r should be positive. If the slope is negative, then it's a negative correlation and r should be negative. In our case, the slope is 48. It's a positive 48, not a negative 48, which means r should be positive. So we're looking for the positive square root of 0.67. So r is going to be the positive square root of 0.67, and that gives us 0.82 approximately, if we round to 2 decimal places. 0.82, which is a pretty strong positive correlation. And that's our answer. So, I hope that helps, and until next time.